Alright, so what is the nth term and the fourth term of the geometric sequence given that its first term is 5 over 2 and its common ratio is negative 1 over 2? So I need to cover what a sequence is first. So a sequence is basically a sequence of numbers that follows a pattern. So for example, a really simple sequence would probably be this sequence here, which is 1, 2, 3, 4, 5. So this is a arithmetic sequence, where each term in our sequence is plus 1. So you see here that our first term is 1, our second term is 2, so plus 1, plus 1, plus 1. So you see here the pattern is plus 1, plus 1. I don't need to explain it any further. Okay, so a geometric sequence, all right, follows a pattern where the next term in the sequence is multiplied by what we call a common ratio. So a very simple one will probably be 2, 4, 8, 16, 32. Well, the common ratio here is 2. So we multiply by 2, we multiply by 2, and each term in the sequence, the next term in the sequence is the multiplication of the common ratio by the last term in the sequence, okay? All right, cool. So let me rewrite the sequence out again. And so on and so forth, okay? All right, so we can rewrite 4 as 2 times 2, right? We can also rewrite 8 as 4 times 2, or we can rewrite this as 2 times 2 times 2. So do you see a pattern here? If I keep going, this can be written as 8 times 2, but this can be written as 4 times 2 times 2, but this can be written as 2 times 2 times 2, right? So if I were to write the general formula for each term in the sequence, it would be this, okay? So we would have our term that we're looking for, which is an, and it would be the first term of our sequence times the common ratio to the power of n minus 1. So we see here that 2 is also equal to 2 times 2, 1 minus 1, which is just 0, so it's 2. 4, okay, let me rewrite it here. So 2 equals 2 times 2, which is a common ratio, 1 minus 1, which is equal to 0, so that equals 2. 4 is equal to 2 times 2 to the power of 2 minus 1. 8 is 2 times 2 to the power of 3 minus 1, and so on and so forth, right? So this is the general formula for our geometric sequence, right? Which is, if you're looking for the nth term of our geometric sequence, it's just going to be the first term times a common ratio to the power of n minus 1. All right. So in this question specifically, they're asking us to find the nth term and the fourth term of a geometric sequence with the first term of 5 over 2 and the common ratio of negative 1 over 2. Okay, so if we, whoops. Okay, so if we were to calculate this, so we know that A1 is equal to 5 over 2, and we know our common ratio is negative 1/2. Okay, so given our general formula here, all we have to do is plug it in. So an equals 5 over 2 times negative 1 over 2 to the power of n minus 1. Okay, so this is our nth term. All right, so the fourth term will just be a of 4 equals 5 over 2 times negative half 4 minus to the power of 4 minus 1, or the power of 3. Okay, so that'll be 5 over 2 times negative 1 over 8. Okay, and that gives us negative 5 over 16. All right, cool. So that's how you would be able to calculate the nth term and the fourth term of a geometric sequence. So first of all, we stated what a geometric sequence is, which is a sequence of numbers that follows a pattern of multiplying by a common ratio. In this case, our common ratio here was -half. And then by doing so, we were able to use the pattern of a geometric sequence to find its general formula here. And through the general formula, we're able to find the nth term and the fourth term. So this solution is correct. Good job. Cool. All right. Let's talk about question number 5.